Hello, this is Faroque Ahmed from Bangladesh, MSc in Statistics. At present, I am working as a research associate at Bangladesh Institute of Governance and Management, BIGM, Dhaka, Bangladesh. Now I am going to present our research paper entitled A Comparative Study of Credit Card Fraud Detection using the combination of machine learning techniques with data imbalance solution. My co-author is Ritika Shamsuddin. She is an assistant professor, Department of Computer Science, Oklahoma State University, USA. Now let me share the screen first. Now the pointer, laser pointer option. Okay. So the presentation contents includes the following: introduction, motivation, existing empirical evidence, research gap, research objectives, data description, methodology, empirical results, key findings, policy suggestions, and finally, limitation of the study. Introduction. At first, we will look into the issue. There is a rapid spread of frauds and cybersecurity risks in the digital economy. Since we are dealing with fraud detection, we want to define fraud first. When anyone acts in a false or deceitful way to get some benefit from a process, generally known as a criminal deception or fraud. In several ways, credit card fraud can be conducted: by producing fake or forged cards, by lost or stolen cards, the original site can be cloned, by scanning, by phishing, or by data theft, etc. Now, why the issue is important? Annually, billions of dollars are misplaced by fraudulent activities of credit cards. Around $4 billion is the estimated amount of loss due to the online fraud in 2008, which was 11% higher than the previous year's loss of around $3.6 billion. In this background, fraud detection stands as a prime issue of the modern technology. Now, what is the motivation behind conducting this research? Computationally, fraud detection is difficult because most of the times fraud cases make up less than 1% of the total transactions, which makes the dataset imbalanced in terms of genuine and fraud transactions. That's why conventional methods of fraud detection fails to detect frauds precisely. One another point is that classifiers are likely to guess everything as the majority class when someone uses this imbalanced dataset. This is the prime difficulty of learning from extremely imbalanced datasets. That's why we run an in-depth experimentation where we combine machine learning classifiers or techniques with various class observations balancing techniques to improve our final prediction. Now, existing empirical evidences. There are several studies who focuses on credit card fraud detection on different datasets. For example, the hidden Markov model HMM is proposed by Srivastava and others in 2008. Random forest support vector machine and logistic regression on a real-world dataset is compared by Bhattacharya and others in 2011. Malini and Pushpa in 2017 opined that in fraud detection, k-nearest neighbor and outlet detection techniques can also be proficient. In the paper of Kajemi and Jarrabi in 2017, a contrast was made between deep learning methods and some traditional algorithms. Accuracy of approximately 80% was achieved by most of these tested methods. At this point, I want to draw your attention on some literatures who works on the European cardholders dataset, on which we also ran our classifiers or implemented our classifiers. So on this dataset, a mixture of certain classifiers like SVM, support vector machine, gradient boost, logistic regression is used by Mishra and Gorpade in 2018, which returns a high recall of over 91%, which is quite good. Dhankad and others in 2018 uses altogether following algorithms: logistic regression, XBoost, support vector machine, MLP, decision tree, gradient boost, KNN, K nearest neighbor, random forest, naive Bayes, and stacking classifier, which is a mixture of several machine learning classifiers. Due to a detailed data pre-processing, over 90% accuracy was accomplished by all of the algorithms. With the accuracy and recall value of 95%, stacking classifier was the best classifier among those. Wang and others in 2018 used neural network and gave 97% recall and 96% accuracy due to some optimization algorithms they used. The random forest algorithm provides the top result according to Dornadula and Gita in 2019 by means of different matrices such as accuracy, recall, and precision. So from this discussion, we can come up with following research gap. Most of the researchers don't usually focus on the data imbalance, even though imbalanced data can produce biased machine learning outcome or prediction. That's why we run a thorough experimentation where we combine machine learning techniques, with various class instances balancing techniques to increase accuracy and preciseness of correct prediction. Though previous studies generally used some common single methods, such as oversampling, undersampling, etc., for the data imbalance solution. Moreover, they use it for only 3 or 4 classifiers to predict the fraud transactions. So based on this research gap, our main objective is to implement a comparative study among 6 machine learning algorithms along with 4 data imbalance solution method to find out the best combination, of classifiers and data imbalance solution techniques that can predict fraud transactions more precisely than before. To be more specific, we have used 6 machine learning classifiers such as logistic regression, support vector machine, naive Bayes, random forest, decision tree, and K nearest neighbor, which are implemented in Python. The class imbalance solution was addressed by 4 sample selection methods, such as undersample, oversample, smart, and addressing. Primarily, all these 6 classifiers were implemented on the primary imbalanced dataset. Then consecutively, all these classifiers are implemented again on those 4 sample datasets for comparison. So in total, we have 5 datasets and 6 classifiers. So we have got 30 different models for our final comparison. We have compared these 30 models based on 5 measurement criteria. Now the dataset contains transactions made by credit cards in September 2013 by European cardholders. This dataset presents transactions that occurred in just 2 days, where we have 492 frauds out of 0.285 million transactions. The dataset, from this information, we can clearly see that how imbalanced the dataset is. The positive class or fraud class accounts for only 0.2% of all the transactions. Our dataset contains in together 31 variables. Among those, variable 1 to variable 28 goes through a dimensionality reduction technique, which is called PCA, due to some confidentiality issues of the customers. And the remaining variables are time, which is the number of seconds elapsed between current transaction and the first transaction in the dataset. Amount is the transaction amount, and class is the response variable, which takes value 1 in case of fraud and 0 in case of genuine transactions. Our methodology consists of 5 pages, which are assembly of data, pre-processing of data, training of classifiers, testing of classifiers, investigation of classifiers performance. Finally, we are focusing on this pre-processing of data and investigation of classifier performance, these two pages. We are investigating the performance of the classifiers based on 5 measurement criteria. These are accuracy, area under the ROC curve, AUC, precision score, recall score, and finally F1 score. Our data imbalance solutions are the undersampled, oversampled, smart, and adjacent dataset, where undersampling reduces the observations from the majority class to balance with the minority class. On the other hand, oversampling just replicated observations from the minority class to balance with the majority class. Smart synthesizes new data from the minority class to balance with the majority class. And adjacent, it also synthesizes new data from the minority class, but it do not replicate the same data of the minority class. Additionally, it uses kernel density distribution for the replication of new dataset. Naturally, the original dataset is partitioned into training and test dataset. We have 70% of data. We have used 70% of data as our training dataset, and the rest 30% dataset is used for testing dataset. We have got the following ROC curves for 30 different models. Finally, we got 6 ROC curves for 6 classifiers. Here, the first ROC curve is showing the performance of KNN classifier on imbalance dataset, KNN on undersampling dataset, KNN on oversampling dataset, KNN on small dataset, and KNN on adjacent dataset. And the AUC values are there. The second graph, ROC curve, is showing the performance of random forest classifier. The third graph is showing the performance of the naive-Bayes classifier, where the fourth graph is showing the performance of SVM, support vector machine classifier. Here the AUC values are there, and the curves are also there. And the decision tree classifier is depicted by this graph, and the last graph is showing the performance of logistic regression classifier. So on average, we can see from these curves that the naive-Bayes classifier and the logistic regression classifier are performing poorer than others. Finally, for the evaluation of the overall performance of classifiers, depending on accuracy, AUC, precision score, recall score, and F1 score, we have got this following evaluation performance evaluation table. Here, the ranking is done based on the aggregate value of these 5 measurement criteria, values of these 5 measurement criteria. Finally, we can see that the random forest classifier implemented on oversampling dataset ranks first in terms of accuracy, AUC, precision score, recall score, and F1 score as well. From this table, we can see the rest of the models from number 16 to 30. And from this table, it is also clear that the performance of all classifiers on imbalanced dataset, naive-Bayes imbalance, KNN imbalance, LR imbalance, decision tree imbalance, SVM imbalance, LR imbalance. So all these all these imbalanced dataset are ranked in the lower part of the table. So our key findings, we find that random forest with oversampled dataset provides most accurate as well as precise result in terms of all 5 criteria. Both from ROC and performance evaluation table, it is clear that classifiers on imbalanced dataset performs poorer than others. And on this data set, neural network optimized with Whale algorithm was used by Wang and others. They got 96% accuracy and 97% recall, where we got 99% accuracy and 100% recall rate by the combination approach of this random forest classifier with oversampled data set. We can suggest two policy to the banking sector and financial sectors. They can use this suggested machine learning based combination approach to minimize the debit or credit card frauds on real time. And banks can also use this combination technique to their core banking software to classify unusual daily transactions on real time. We have a limitation. The limitation is the data used for this analysis is not recent due to unavailability of big data sets in Bangladesh. In fact, the data is taken from European cardholders collected on September 2013. And finally, future scope of this study is that this study can be further improved by using an improved version of random forest oversampling technique. Ren and others in 2020 proposes a fuzzy representativeness difference-based oversampling technique using affinity propagation and the chromosome theory of inheritance. So using this technique, improved technique, we can further improve our paper. So finally, thank you for your patience. Thank you very much. That's all from me.